Okay, this is to help you get ready for the retest on right triangles. So be sure you pay close attention and you answer the questions correctly because you need to pass this before you're allowed to retake the test. So question 1, from angle M, label the opposite side, adjacent side, and hypotenuse. So the first thing you need to do is put theta at angle M. The opposite side is cross. It helps if you draw the arrows. That would be your opposite side, MP. The adjacent side is the side beside it, so that would be side MN. And the hypotenuse is always the longest side, so that would be side MP. On this one, from angle C, label the opposite side, the adjacent side, and the hypotenuse. Number 2, write each trigonometric ratio as a fraction. Sine A. It's going to help if you put theta at A. Remember, sine is opposite over hypotenuse. So that's going to give you 8 over 17. So write your answer as a fraction. Cosine is adjacent over hypotenuse. So that's going to give me 15 over 17, which is the hypotenuse. And tangent is opposite over adjacent. So that would give me 8 over 15. This one, same thing. Write each trigonometric ratio as a fraction. Number 3, find the measure of angle A. Show and explain your work. So it's going to help if you put theta at angle A. I'm finding angle A, so that means I need to use trigonometric ratio because I don't have an acute angle to subtract from, 90. So I'm going to compare the opposite side and the adjacent side. So if I use SOHCAHTOA, I'm comparing the opposite and adjacent. I'm going to use tangent. I don't know what theta is, so I put the theta symbol. Equals the opposite side, which is 3, over the adjacent side, which is 6. Now, if we need to find an angle, which is theta, we need to remember that you have to press shift to find an angle. So if I get my calculator and I press shift, tangent, 3 over 6, my fraction, that gives me theta equals 26.5 degrees, so that rounds to 27 degrees. Number 3, find the measure of angle A. Show and explain your work. Again, if we want to find angle A, we're going to put theta on angle A. We want to compare the two sides, so this is my adjacent side and my hypotenuse. So we're going to use SOHCAHTOA to see which trig ratio we use. So in order to do that, we're going to use cosine. So we would write cosine theta, because we don't know it, equals the adjacent side, which is 9, over the hypotenuse, which is 19. Don't forget to press shift. Find theta. Number 3, on this one's another example of finding the measure of angle A. Do the work. Number 4, find the length of BC. So whenever you want to find the length of a side, you want to identify which side it is and put X there. If theta is going to be 35, X is going to be your opposite side, and 8 is going to be your hypotenuse. So use SOHCAHTOA to determine which trig ratio you're going to use. Since I'm comparing my opposite and my hypotenuse, that would give me the sine part of SOHCAHTOA. So I'm going to write down sine theta is 35. My opposite side is 8. My hypotenuse, or x in my hypotenuse is 8. So if I want to find what x is, I need to make a proportion and cross multiply. This tells me to multiply sine 35 times 8 to find out what x is. So if I do that, I get my calculator and I say sine 35 times 8. And that tells me that x is going to equal 4.58, which rounds to be 4.6. Same thing on this one. Again, I want to find the length of BC. So I put an X on the side I'm looking for. I identify the sides from theta. Theta is 26, so this would be my opposite side. And 15 would be my hypotenuse. So those are the two sides I'm comparing. We want to use SOHCAHTOA to determine which trig ratio we're going to use. So since I'm comparing opposite and hypotenuse, I set it up like this. So I would say sine theta is 26 degrees. That compares the opposite, which is x, and the hypotenuse is which 15. I want to set up my proportion, so I put it over 1, and I cross multiply to get my answer. This one I want you to do. So it gives you a few minutes to work this out. Number 5, find the length of AC. So I want to identify where AC is by putting an X on it. If 36 is my angle, my theta will be 36, so that would be the adjacent side. 15 is my hypotenuse. So I'm going to use SOHCAHTOA to determine which trig ratio I want to use. So since I'm comparing the adjacent and hypotenuse, I'm going to use cosine. So I'm going to write my proportion. Cosine theta, which is 36, equals my adjacent side, which is x, over 15, which is my hypotenuse. To solve it, I want to set up a proportion. So I put it over 1, and I cross multiply. This tells me to multiply cosine 36 times 15, and that gives me x. So I need to get my calculator out, and I'm going to say cosine 36 times 15, and that tells me that x is going to equal 12.28, which rounds to 12.3. So AC equals 12.3. This one wants me to find the length of AB. So AB, I put an X. I label theta as 24. AC is my adjacent side. AB is my hypotenuse. So I'm going to use SOHCAHTOA to determine which trig ratio I'm going to use. Since I'm comparing adjacent and hypotenuse, it tells me to use cosine. So I would say cosine theta, which theta is 24, so I can substitute 24 in there. The adjacent side is 16, and my hypotenuse is x. I want to set up my proportion. This one tells me to divide, so use your calculator and get the answer. This one wants us to find the length of AC. Number 6, find each of the angle measures and the side length. Show and explain your work. First, I ask you to find BC. So BC, if I put an X there, I know two sides, so I can use the Pythagorean theorem. Remember, your hypotenuse always has to be c squared, so my hypotenuse is 25. I can substitute in 13 for either A or B. So I want to square 13. 13 times 13 is 169. 25 plus 25 is 625. If I subtract 169 from both sides, it's going to give me B squared equals 456. And to find the answer, I need to take the square root of 456. So that's going to give me 21.35 or 21.4. If I want to find the measure of angle A next, I don't have a complementary angle to subtract to find A, so I've got to use a trigonometric ratio. I'm going to compare the adjacent side and the hypotenuse, so that would tell me to use cosine theta equals adjacent is 13, hypotenuse is 25. So remember, if you don't know theta, you have to press shift. So I'm going to press shift cosine 13 over 25. And that tells me that angle A is 58.66 or 59 degrees. And the last part of this question wants me to find angle B. So the easiest way to find angle B would use the fact that angle A and B are complementary. So 90 minus 59 degrees is going to give me 31 degrees. So angle B would be 31 degrees. Next on this one, again, I want to do the same thing. I want to find AB. So if I want to find AB, I'm going to put an X there. I want to use the Pythagorean theorem. A squared plus B squared equals C squared. Remember, your hypotenuse always has to be C, so I don't know it. So I would say 8 squared plus 17 squared equals C squared. And work that out to find the value of AB. You do that. Next, I want to find the value of angle A. So if I put theta on angle A, that would tell me that I want to use my opposite side and adjacent side. So that would be tangent. So I say tangent theta equals opposite, which is 17, over adjacent, which is 8. Remember, when you're doing that, you need to press shift. So use your calculator to find angle A. And the last thing I want to do is find angle B. So to find angle B, I'm going to subtract what I get from angle A, and that's going to give me the measure of angle B. On this one, I want you to use the Pythagorean theorem to find AB. Now that you know angle AB or side AB, I want you to find angle A. Use the inverse trigonometric ratio to find angle A. And then finally, I want you to use the fact that angles A and B are complementary to find the measure of angle B. On this is an application problem. A 15-foot ladder leans against the building and forms an 80-degree angle with the ground. Part A wants you to the nearest inch, and we're going to just do feet. How high does the ladder reach? Show and explain your work. So the first thing that I do is I draw a triangle, since we're working with the right triangles. Remember, if the ladder is leaning, the hypotenuse is the side that's leaning. And it forms an 80-degree angle with the ground. That would be 80 degrees at the acute angle on the bottom. So if I want to find how high, that's your vertical measurement, I want to use my trig ratios to do that. So set up your trig ratios. You're going to compare the opposite side and the hypotenuse. So that's going to use your sine function. And remember, theta is 80. So that's going to give you opposite over hypotenuse. Make it a proportion and cross multiply to get your answer. On this part, is it possible for the ladder to reach the building if the base of the ladder is 15 or 5 feet from the base, and I should have said from the base of the building? So again, we're going to use our 15-foot ladder as leaning, our 80-degree angles on the ground. We want to know if this could be 5 feet. So a few ways you could do it. You could use your opposite side or your adjacent side and your hypotenuse. You could check to see if cosine 80 is equal to adjacent over hypotenuse. Check and see if those values are equal. If they are, then it's possible. If it's not, then it's not possible. On this one, angle X and angle Y are complementary angles in a right triangle. The value of tangent X is 14 over 48. What is the value of sine Y? So what you need to do is you need to label it. If angles X and Y are complementary, then we know those are the acute angles in the right triangle. So you could put X on one acute angle and Y on the other acute angle. Since tangent compares opposite over hypotenuse or adjacent, then opposite X would be 14 and adjacent to X would be 48. Now they want you to find sine of Y. So put theta on Y and find the sine of Y. Number 9, then triangle PQR is similar to triangle XYZ below, which must be true. So what you need to do is you need to locate your angles. You want to say, is sine Q, is angle Q congruent to angle X? Next you want to know sine R and sine Z. So is angle R congruent to angle Z? Next, we want to know tangent Q and tangent Z. Is angle Q congruent to angle Z? And then finally, they want to know tangent R is equal to tangent X. So you ask yourself, is angle R congruent to angle X? So by going through the answers, determine the answer of the question. Number 10, a geologist's eye level is 6 feet above the ground. His measure of angle of elevation to the top of the erupting geyser is 24 degrees. If the scientist is standing 90 feet from the base of the geyser, what is the total height to the nearest foot? So you're going to compare, this will be theta. You want to compare the opposite side and the adjacent side. So if we use Sakatoa, we know we're going to use tangent. So we're going to say tangent 24 equals opposite over adjacent. And you're going to find out that X equals. Then remember, X doesn't go all the way to the bottom of the geyser. So to get your final answer, you need to add 6. So that will give you your answer would be number 11. Number 11 says triangle NOP is a right triangle with right angle P is shown. What is the true value? If I compare the two sides based on angle Y, that's going to be my adjacent side and my hypotenuse. So that would give me cosine Y equals 7 over 8. Now, if you notice all your answers are not talking about angle Y, they're talking about 90 minus Y. And the angle that equals 90 minus y would have to be the other acute angle. So angle O would have to equal 90 minus y. That's how you would find angle O. You would subtract the measure of the other acute angle from 90. So if I want to put theta at angle O, that's going to make 7 my opposite side, and 8 is still my hypotenuse. So if I'm comparing my opposite side and my hypotenuse, I'll no longer be using cosine. So now determine the answer. Number 12. Number 12 says, in the figure, triangle ABC is similar to triangle XYZ. Given that the measure of angle A is 50, so I'm going to put 50 at angle A, and angle B is 100, so I put 100 at angle B. What is the measure of angle Z? I want to find how many degrees angle Z is. Well, I can tell by looking at the triangle that angle Z is going to be congruent to angle C. Same way in the statement. Angle C and angle Z are congruent. Even though triangle XYZ is smaller than triangle ABC, the angle still must add to give you 180 degrees. So, to find the measure of angle C, I'm going to add 100 plus 50, and that gives me 150. And to find the missing angle, I need to subtract that from 180. So that's going to give me 30. So I know angle C equals 30. So what does angle Z equal? 13. It says, consider the triangles shown, which can be proved that the triangles are congruent. You have to label the marks. If I look at the marks at the letter B, that's inside the triangle, so that is an angle mark. If I look at the mark at the letter A, that's inside the triangle, so it's an angle mark. If I look at the slash mark between the letters A and C, that is not inside the triangle, so it is a side. Now, notice that the side that's between angles A and B is here. That's not where our S is. So I know my answers cannot be A or D. I've got to use one with 2 letters. So which is the correct answer? 14. Which transformation of triangle HIJ does not result in a congruent triangle? So let's look at the first one, A. If I want to translate 1 unit right and 2 units up, that's what the transformation would look like, followed by a dilation by a factor of 3. So that's what it looked like. Would you say that this shape is congruent or not congruent to the pre-image? B. A reflection across the x-axis. That's what it would look after you reflect the pre-image across the x-axis. Followed by a rotation about the origin. There's your rotation. So this would be your image, and this is still your pre-image. Would you say that your image is congruent or not congruent to the pre-image? C. A dilation by a scale factor of 2 would look like this, followed by a dilation of a scale factor of 1/2 or 0.5. So here's your image or your pre-image, and here's your image. Would you say that your image is congruent or not congruent to your pre-image? D. A rotation about the origin. So here's what it looks like when you rotate it about the origin, followed by a translation of 2 units left and 3 units down. So if you look at your image, how does your image compare to your pre-image? Congruent or not congruent? So thinking about the pictures we just saw, which is the correct answer? Which does not result in a congruent triangle? 15. Which transformation results in a figure that is similar to the original figure but has a greater area? So let's look at our answer choices. If I want a dilation of triangle QRS by a scale factor of 2, I tell it to dilate by a factor of 2, and this is my image. Would you say that's larger or smaller than my preimage? Let's look at B. A dilation of QRS by a scale factor of 1. So if I put in my scale factor of 1, there's my preimage. Notice I only see one figure. That means my preimage is on top of my image. C. A dilation of triangle QRS by a scale factor of 0.5. So if I tell it to do a scale factor of 0.5, I compare. This is my image. How does my image compare to my preimage? D. A dilation of QRS by a scale factor of 0.25. So if I use GeoGebra to tell it to factor it by 0.25, here's my comparison. This is my preimage. This is my image. So how does my image compare to my preimage? Use the pictures from what we've just gotten through doing to determine which transformation produces a figure that has a greater area.